Okay, so we just learned about how to assign the oxidation states of each element in a compound. Earlier in the last week class, we had seen how to decide the oxidation process and the reduction process. Okay, so we have already covered the oxidation and reduction in two terms. One is in terms of oxygen and in terms of electrons, and third was oxidation state, which we would continue. So the process of oxidation and process of reduction. First, we learned in terms of oxygen. So in terms of oxygen, how is oxidation defined?
So there's gain in oxygen as oxidation.
Yeah, so any substance when gains oxygen, we say that it has got oxidized. So oxidation is gain of oxygen. So reduction will be what?
Loss
Loss
of
of
oxygen.
So whenever any oxide loses oxygen, we call this as reduction. Then we learned same oxidation process and reduction process in terms of electrons,
so the oil reactant.
the
It's
oil
opposite.
reactant. So oxidation is what in terms of
The
electrons?
loss of electrons.
Loss of
Yeah, loss of electrons is oxidation. So whenever any substance in any chemical reaction, whenever any substance loses electron, we say that that substance has got oxidized. So we remember this by the word oil. Oxidation, O for oxidation, I for is, and L for loss
Loss.
of electron. So oxidation is loss of electron. And similarly, reduction is gain of electron. So whenever any substance gains electrons, we say that that substance has got reduced, and this we remember by the mnemonic RIG. R reduction, I is, G gain of electrons. So oxidation is loss of electron, reduction is gain of electron. Now we were learning the third concept, third definition of oxidation and reduction, which was in terms of oxidation state. In terms of oxidation state. Okay, now listen to this. We just learned how to assign the oxidation state. We just learned how to assign the oxidation state. But how do I decide on the basis of oxidation state if any substance is getting oxidized or reduced? Okay. Whenever during the reaction, if any substance ka oxidation number or oxidation states increases, there is an increase in the oxidation state, we say that that substance has got oxidized. Okay, I repeat, you should, now you have learned how to assign the oxidation state. So what you should do is that you should check the oxidation state of an element, of an atom in the reactant, and check the oxidation number of same atom in the product. Okay, you should check the oxidation number or oxidation state of an atom in the reactant, and you should check the oxidation state of the same atom in the product and see, is it different? Is the oxidation number of the atom in the reactant and the product different? If yes, then you check, is it increasing or decreasing? From reactant to product, is it increasing or is it decreasing? If it is increasing, then we say that that substance has got oxidized. And if suppose it decreases, so if there is a decrease in the oxidation state, then we say that that substance is getting reduced. Okay, we will see examples.
so you were lagging. Can you repeat the decrease?
Yeah, okay. Okay, so I was explaining how is oxidation and reduction defined in terms of oxidation state. In terms of oxidation state. So you should check the oxidation number or oxidation state of an atom in the reactant and in the product. In the reactant first and then in the product. Just see if it's remaining same on both the sides or it's different. If it's remaining the same, which means that it is neither getting oxidized nor getting reduced. If it's increasing, oxidation rate is increasing. From low value, it's going to the high value. Then we say it's getting oxidized. And if it's decreasing from high value, it's going to the low value. Then we say it's getting reduced. Okay. So we'll see an example now. One simple example we'll take. Sulfur plus oxygen gives sulfur dioxide. Okay. Now, you need to check the oxidation number of every element. What is the oxidation number of sulfur here?